Hi and welcome to the first video in the probability series. Probabilities can be used to make predictions. For example, if you're told that an event has a probability of occurrence of 90% and that of another event is 10%, then the event with a higher probability is more likely to occur. So imagine a scenario where you have two boxes. In one box you have 5 spheres and in the other box you have 10 spheres. And you're told that in each case, so we've called this case 1 and case 2. In each case, there's one sphere which contains golden coins, and you're then asked to pick just one sphere, and if you pick the sphere with the golden coins, you basically won the game. So you can call this a first game and you call this second game. In the first game you have 5 spheres to choose from, but you can only choose one. In the second game you have 10 spheres to choose from and you can only choose one. Only one sphere has a golden coin. Your objective is to pick the sphere with the golden coin. So let's start with game 1. In case 1, there are 5 spheres. Assuming this sphere was the one with the golden coin, that means I'll be wrong if I chose this sphere, I'll be wrong if I chose this sphere, and I'll be wrong if I chose this sphere. In case 2, if this sphere was the one with the golden coins, then I'll be wrong if I chose this sphere, this one, 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 this one. So what am I trying to stress? In case 1, because there are only 5 spheres and only one correct one, I only have 4 ways. I have 4 ways of being wrong. 4 ways of being wrong. In case 2, there are 10 spheres. Of course, like I said, only one has the golden coin. So I have 9 ways of being wrong. So there are more ways for me to be wrong in case 2 than in case 1. And that means that I have a better chance of winning in case 1. So that's a good way to think about probability. So in this case, the probability can be expressed as follows. If I just use a fraction, I'll say 1 in 5. There's only one way of winning out of 5 possibilities. Here, there's also only one way of winning, but it's out of 10 possibilities because there are 10 spheres. So here we have the result. So this is the sphere with the golden coins. Here we have this is the sphere with the golden coins. But the key thing to note is that there are more ways of being wrong in this case, and there are fewer ways of being wrong in this case. So the case where you have fewer ways of being wrong is the case where you have a greater probability of winning. So I just want you to think of probabilities in that sense of the number of ways you can win or the number of ways you can lose. It's a good way to just start with that. Now we're going to look at the means of expressing probabilities. One common way is to use a linear scale varying from 0 to 1. Now, when the probability of an event is 0, so this is the left end of this scale anyway. When the probability of an event is 0, that means the event is an impossible event. That means that event will not occur. So an event with a probability, which I'm going to shorten to PR, if the PR of the event, probability of the event is 0, that event is an impossible event. So that should be a 0. If the probability of an event is 1, that means that event is certain to happen. That means that event will definitely happen. So we have 2 ends of this scale. At one end, you have a probability of 0, and that means that event will not occur. At the other end, the other extreme, you have a probability equal to 1. And that signifies that the event will definitely occur. Anything in between has a probability that's in between these 2 extremes. So, but the key thing to note is an event with a probability of 0.5 of occurring has a higher chance than an event that has a probability of 0.25 of occurring. So as you can see, if we move from left to right on this scale, the chances of an event occurring increases. If you think of all these numbers as probabilities. So that's the linear scale. We're representing probabilities with numbers, but the numbers vary from 0 to 1, where 0 means the event is impossible. A probability of 1 means the event is certain to happen. And just one key thing to notice is that the higher the number, the greater the probability. The lower the number, the lesser the probability of that event occurring. Here's an example question. It says, event A, B, C, and D have the following probabilities. As you can see, we have a table. The first column has the event. The second column has the probabilities of the events occurring. So the probability of event A occurring is 0.4. The probability of event B occurring is 0.85. The probability of event D occurring is 1. So here's the first question. Which event is most likely to occur? Clearly from the probabilities you can tell that a linear scale is being used. So on the linear scale, probabilities range from 0 to 1. The highest probability of an event on a linear scale is 1. And we can see that event D has the highest probability. It has a probability of 1. 1 is larger than any other number here. So we know that event D is the most likely to occur because it has the highest probability. Second question asked, which event is least likely to occur? And that has to be the event with the least probability. From the table, we can see that the smallest number here is 0.2. The smallest probability is 0.2. And that corresponds to event C. So event C is the least likely to occur. Here's the third question. It says event B is more likely than event A. True or false? So I'll just rephrase that. Event B is more likely to occur than event A. True or false? What's the probability of event B? 0.85. So I'll just use PR to represent probability. Probability of event B is 0.85. And the probability of event A is 0.4. You can tell that the probability of event B is greater than the probability of event A. 0.85 is greater than 0.4. Therefore, this statement is true because the event with the larger probability is more likely to occur. Probabilities can also be expressed on a percentage basis. A percentage scale varies from 0 to 100%, as opposed to a linear scale which varies from 0 to 1. Now on this scale, an event with a probability of occurrence of 0% is an impossible event. An event with a probability of occurrence equal to 100% is a certain event. That event would definitely happen. So we have a scale here. From left to right, the probabilities increase, and that means that the chances of occurrence of the relevant event is getting higher. So let's put it this way. If an event has a probability of 75% and another event has a probability of 50%, the event with a probability of 75% is more likely to occur than an event with a probability of 50%. If an event has a probability of 25% and another event has a probability of 100%, the event with the probability of 25% is less likely to occur than the event with a probability of 100%. In fact, the event with a probability of 100% will definitely occur. The event with a probability of 25% may occur, but has a lower chance of occurring than an event with a probability of 100% or an event with a probability of 75%. So that's the main idea. So now we have a percentage scale. And we've also looked at the linear scale. So here's an example question. It's similar to the previous example. This one says, events A, B, C, and D have the following probabilities. But this time, the probabilities have been given in a percentage scale. Event A has a probability of occurrence that's equal to 40%. The probability of occurrence of event D is 100%, so you can easily understand this table. The first question asks the following. Which event is the most likely to occur? Of course, that's going to be the event with the highest probability. On this table, we have the following probabilities: 40%, 85%, 20%, and 100%. The highest is 100%, and that corresponds to event D. Second question asked, which event is the least likely to occur? That's definitely going to be the event with the smallest probability, and that's 20% here, so event C. And finally, it says event B is more likely than event A. So event B is more likely to occur than event A. True or false? Event B has a probability of 85%. Event A has a probability of 40%. The probability of event B is greater than the probability of event A. That means event B is more likely to occur. So this statement is true. It's important to be able to convert from one scale to another. So if you have a probability given in a percentage scale, you need to be able to convert it to a probability in the linear scale. So what's a percentage scale? 0% to 100%. It's a percentage scale. And the linear scale is from 0 to 1. So numbers ranging from 0 to 1. 0 and 1 included, of course. And the percentage scale is for values ranging from 0% to 100%, 100% and 0% included. And the simple procedure is to divide by 100 and drop the percentage symbol. So if you have a probability of an event equal to 90%, you want to convert it to the linear scale, all you have to do is divide 90% by 100 and drop the percentage symbol. So I'm going to drop the percentage symbol and divide by 100. What do I get? I get 0.9. So an event with a probability of 90% also has a probability of 0.9. 90% just is the probability when one's using a percentage scale, and 0.9 is probability when using a linear scale. I'll do another example. The probability of an event is 75%. To convert it to a linear probability, all one has to do is drop the percentage symbol and divide the number by 100, and that gives 0.75. So a probability of 75% is equivalent to a probability of 0.75. And next we're going to look at converting from a linear scale to the percentage scale. All you have to do in this case, or in such cases, is multiply the given probability by 100 and just append the percentage symbol. Really simple. So if you're told that the probability of an event is 0.9, this is a probability given in the linear scale. To convert it to a probability on the percentage scale, all you have to do is multiply by 100 and append the percentage symbol. Now 0.9 times 100 is 90%, and that's all. So I'll give another example. If you're given a linear probability like 0.65, to convert it to percentage scale, all you have to do is multiply by 100 and just append the percentage symbol. 0.65 times 100 is 65, and then the percentage symbol just goes next to it, 65%. Really easy stuff. So here's an example, and this pertains to the conversion of probabilities from one scale to another. So in the first column we have event. So for example, you have the probability of winning the lottery. You have the probability of winning a football tournament. In the next column you have linear scale probabilities. In the last column there are percentage scale probabilities. All we have to do now is convert probabilities from either scale to the other. So what am I saying? In this case, the first case, the probability of winning the lottery, we're given the probability as being 1%. What we need to do now is find the linear equivalent of this 1%. In the second case, probability of being struck by lightning, we're given a linear probability of 0.7. There's a gap in the percentage column, so we need to find the equivalent percentage probability. So let's start with the first one. We're given that the probability of winning the lottery is 1%. In the linear scale, to determine the result, all one has to do is drop the percentage symbol and divide by 100. So I'm dropping the percentage symbol and dividing by 100, and that gives 0.01. So a probability of 1% is equivalent to a probability of 0.01. The next example, probability of being struck by lightning. We're given 0.7 as the linear probability. To find the percentage probability, all we have to do is multiply 0.7 by 100 and append the percentage symbol. So this is equal to 0.7 times 100, which is 70, and then the percentage symbol. So we have 70% as a probability of being struck by lightning. Now I just note that the probabilities given here are just fictitious. They're just made up. So moving on, the probability of winning a football tournament is given as 0%. We basically need to fill in the gap, find the linear probability. To convert from a percentage probability to a linear probability, all we have to do is drop the percentage symbol and divide the number by 100. 0 divided by 100 is 0. So this event is an impossible event for whatever team this is. Now to the last case, the probability of winning the raffle. The linear probability is given as 0.1. The percentage probability is obtained by multiplying the linear probability by 100 and appending the percentage symbol. So simplifying this gives, well, 0.1 times 100 is equal to 10, and the percentage symbol is added, so a probability of 10% is equivalent to a probability of 0.1, and the table is complete. So just the key thing is, if you're going from the linear scale to the percentage scale, all you have to do is multiply by 100 and append the percentage symbol. If you're going from the percentage scale to a probability in the linear scale, all you have to do is drop the percentage symbol and divide the number by 100. It's as simple as this. So far, we've just been talking about the probability of an event occurring. What about the probability of an event not occurring? So for instance, if I tell you that the probability of an event A occurring is 0.6, and I'm not going to ask you what is the probability of event A not occurring. Well, for a linear scale, if the probability of an event occurring is x, the probability of that event not occurring is given by 1 minus x. If the probability of an event occurring is x%, the probability of that event not occurring is given by 100% minus x%. So this x represents a probability in percentage. So for instance, you have this example here. We're given that the probability of A occurring is 0.6. So this was dealing with a linear scale probability. The probability of A not occurring is going to be represented with the same notation, but with the line above event A. So you can read this as not A. The probability of not A. The probability of event A not occurring is given by 1 minus x. In our case, x is 0.6. So probability of A not occurring is 1 minus x, which is 1 minus 0.6, which is equal to 0.4. If you're given that the probability of event B occurring is 0.3, the probability of event B not occurring is equal to 1 minus the probability of event B occurring, which is equal to 0.7. The probability, so we're just going to focus on probabilities on the percentage scale. So probability of event A occurring is given as 70%. The probability of event A not occurring is given by 100% minus x. In our case, x is 70%. The probability of the event occurring. So 100% minus, well, I'll write the probability of A, which is equal to 100% minus 70%, which is equal to 30%. That's probability of A not occurring. So I'll just give you a short way of, well, just a sort of formula, which is what this does, but I'll just put it in a different form. If the probability of an event A occurring is equal to this, the probability of the event not occurring is equal to 1 minus the probability of event A occurring, or is equal to 100 minus the probability of event A occurring. So there are two formulas. This first one applies when the probability of A occurring is given as a linear probability. This second one applies, so probability of event A not occurring is equal to 100 minus probability of A occurring. This applies when you're given a percentage probability for the probability of A. So this is the relationship between, I'll just write it neatly on this side. Let's write it neatly. So this first equation applies when you're dealing with linear probabilities on a linear scale, let me put it that way. And the second equation applies when you're dealing with probabilities on a percentage scale. So if the probability of an event not occurring is given, any of these formulas can be used to determine the probability of that event occurring. Or let me just put it this way, the relationship between the probability of an event not occurring and the probability of an event occurring is this, or this, depending on whether you're using a linear scale or percentage scale. So for instance, if you're told that the probability of an event not occurring is 0.3, what is the probability of that event occurring? What is P RA? Well, all you have to do is use equation 1. In equation 1, the left hand side says probability of A not occurring. So that's 0. Well, I'll write it out again. This is equation 1 here. In this case, we have that this is 0.3. So 0.3 is equal to 1 minus the probability of A occurring. So to find the probability of A, you just have to make this term the subject of the formula. So what I'm going to do now is swap the left hand side and right hand side of this equation, and doing that gives then I'm going to subtract 1 from both sides, and that gives minus 0.7, and I'm just finally going to multiply this equation through by minus 1, which gives the probability of A is equal to 0.7. Another way to just solve this equation just from here is to add the probability of A to both sides. So 0.3 plus is equal to 1. All I do is add PRA to both sides, probability of A to both sides, then subtract 0.3 from both sides, and that gives one minus 0.3 is 0.7. So it's the same thing. All you have to do is just make this term the subject of the formula. So you just treat this term like you will treat the variable x, and you can get this. You can use this procedure to get 0.7, or this procedure here to get 0.7, the same result regardless of which method you use. Let's try another example. If you're told that the probability of A is equal to 0.6, and you're asked to find the probability of event A not occurring, what do? Well, use just, well, instead of 0.6, I'm going to change that to 60%. So we can do a percentage, an example using a percentage scale. 60%. So what's the probability of event A not occurring? Well, all we have to do is use equation 2, which says that the probability of an event not occurring is equal to 100% minus the probability of that event occurring. I use equation 2 because it applies when you're using the percentage scale, which is what we're using here, because the probability of event A is given as 60%. So the probability of event A not occurring is equal to 100% minus the probability of A occurring, which is 60%. And this gives 40%. So it's that simple.